This is Sujit Christy. I'm here today with another guest, Anish Koshi, a very well experienced cybersecurity and GRC strategist. And what uniqueness is in him is that he's an adventurer. What I mean by adventurer is not necessarily about mountaineering or trekking or things like that, but he's always in pursuit of finding innovative out of the box solutions for everyday problems. And he's also a proponent that collaboration is the way to solve cybersecurity problems, and especially interacting with the new and the current generation. Anish, thank you so much for being here.
Thank you, Sujit, for this opportunity to be here.
Anish, thank you for making time. And today, our conversation is going to be on quantum safe readiness. So, I would like you to tell us, because I think there are so many different types of threats which are out there, and we talk about different technological solutions and different controls. So, why are we talking about quantum, and why are we talking about readiness here?
Okay. So the thing is, all this while we thought quantum computing will reach a position where it can be readily used is quite far-fetched. Now the point here is, as the technology has been enhancing in the last few years, the people working towards it has seen an exponential growth of how they can quickly increase the processors that use quantum computing. So what does that mean is that currently the fastest computer or the quantum computer system is running at around 1100 logical qubits. Now, when it reaches, or when the enhancement reaches a quantum computing of around 10,000 qubits, it is powerful enough to break our classical cryptography algorithms. So today, AES 256 could be safe and is safe, no doubt about it. But once the qubits reach 10,000, then there are chances that our AES can be broken, or other equivalent can be broken. So that is where it is quite alarming for us that, and it's not far-fetched. Today they've said, and the prediction is that, or the forecast is that, by 2030 we will be able to reach the Q day. So it is important that we start taking steps today. So there are multiple threats like fraudulent authentication, forged digital signatures, but one of the most talked about is the harvest now, decrypt later, or some would use it as store now, decrypt later. Why is this a concern? Because many of our classified encrypted documents or the data is kept in for a longer period of time because of multiple requirements. If you take the healthcare, the patent or medicine compositions are encrypted, and it's kept for a very long time. Our government classified documents, or in terms of the passport information, some of the countries keep it issued for up to 10 years, and our financial requirements or financial data records are kept up to 7 to 10 years. So if you take the Q day could reach by 2030, then we are just six years from now, we are there. So that means every data from this point that is being caught on the dark web or is being exfiltrated from the network, right? Those data can be used at the point in time. So the Q day is approaching, and because of that, there is an immense requirement to be ready for a quantum safe system.
So, Anish, I mean, it's very concerning. Right? 6 years from now is not too far away. There's technology which is being innovated or brought into market, which probably has a lot more capability than what potentially we are assuming that it would have or not have. So maybe they could even achieve this by pooling resources from multiple sources. Now, what I would like to understand from you is what should the organization do to uncover the threat, or what should they be doing as a discovery process? Anish?
Okay. Yeah. So, uh, to take a step back, the first point is to identify the requirement here. So that's where regulators and standards, we all know NIST is at a point where anytime they will release the four final algorithms or what needs to be done for being standardized. We've also seen regulators like NSA has come out stating that by 2025 we need to start off the process, and by 2030 or by 2033 they have defined as per the CNA 2.0 timelines. They've given us a time frame. Also, MAS from Singapore has given that there needs to be a proper transition, and that we also see with PCIDSS in their latest version. They have come out in the section 12.3, and when we look into that in the subpoints of 1, 2, and 3, there is an absolute necessity to first understand your inventory, your estate properly. So, and that is why they have defined couple of directions and guidelines. In fact, it's not just these three. In fact, up to last year, there are around 12 different countries that have brought in guidelines and notices, guiding financial institutes and telling them, be ready, and you need to ensure that it's done well. And because we know we've seen it, we moved from MD5 to SHA-1 and now to SHA-2. We have moved from TLS, we've moved from various obsolete or the deprecated algorithms to a new stronger ones. We know the difficulty. The larger the organization, the more complex it gets. In fact, we know globally organizations have said how difficult it is, because when we move from a shorter to a longer one, if our applications are the downstream applications are dependent on that number of bits that are the outputs of the algorithm, we can't just simply change it. We have to ensure that the upstream downstream connectivity are all understood, and that's the first process we need to understand in the discovery process, which is the first step. We need to have a proper inventory of the of your estate. It could be at the application level, it could be network level, in infra, wherever it be. We need to have a stock, and it's just not a stock that, oh, this system and this is the algorithm. So we need to have a set of all the crypto keys and the crypto assets. And it's not just that, but we need to have a connectivity, like what is the upstream, what's the downstream, and where all is it situated. So the inventory should be updated, and for this there should be a proper scanning tool. And sometimes with larger organization which use so many different programming languages, we may need, as I would say, we may need couple of tools that will be able to scan all our assets, all the whole a stream of the estate that we have. Because sometimes some applications may not be able to scan through appliances, right? We are so used to just programming languages, but the OEMs are so rigid that sometimes our scans cannot work. So the organization should find out or need to utilize tool or tools to ensure that the entire estate is properly scanned and everything is discovered.
Very, very interesting points, Anish. Why I say interesting is that we talk about inventory, and in many organizations, when you talk about inventory, they typically restrict it to physical assets, right? Very, very few organizations spend time and effort to discover digital assets. Now, only when you discover the digital assets, you will also understand what actually the composition of that particular digital asset, and one of them being the cryptographic. algorithms or the standards which are being used. Now, the application of cryptographic standards are diverse, right? So as you rightly said, it could be at network layer, it could be at the application layer. When we talk about application, it would be data in flight, data at rest, data in use. So there are multiple places that this can be applied. So I guess, right, from what you just narrated, there's a lot of work for people to do. Now, the question I have is, how does risk management come into play into this? Or some organization have a dedicated team which focus on risk management. What should
Hmm.
be their involvement in this?
So multiple factors. That goes to the second step after we discover is to maintain our inventory, because we know that our certificates and keys gets rotated, and the expiry would be 1 year, 1.5 years. Some of them will be on a session based um, um, keys usage. So where risk management teams would come in is from the compliance side, because we need to know where, as we maintain the inventory. So the first discovery step was more from a static perspective, what we have on right now. But the next step is about maintaining it, and as we move, how does our keys, where all it's getting rotated, where the new keys are coming. And we need to ensure that the capabilities of identifying compliances with regards to regulatory requirement, wherever the risks are higher, which which systems need to be prioritized, all that comes into play for risk management, because they need to be ready once we are moving to the once we come to the step of the q day, and we need to move all our systems into the quantum safe algorithms. Then the tracking happens, how many are yet to be changed, where is the risk. And especially if you're going at the cia ratings at the higher critical ones, there is our risk. So we need to prioritize all that point. Again, it comes to the step before, we need to start piloting them with the lower critical assets to identify common issues, and that we can oversee that. So the risk will have to find out how many such issues we have identified from the pilots that we have done, so that that can be covered in the critical assets. So there's a lot of work, especially from the compliance side, from the standard perspective, where we need to be tracking.
That's a very important takeaway, Anish, right? I mean, when I say very important takeaway, try a pilot. Look at a low impact system, try and discover as many as possible and see whether that would exist throughout the organization. And I guess then you're getting into a stage of impact assessment, right? Before you transition or transform. And there could be certain applications where you may have to rehash it completely, right? Because you probably hard coded certain things. It may not be dynamic, right? Key management may be not there at all, or it's probably still using very weak algorithms or standards. So for me, the takeaway is that we need to pay attention to it. We need to have one specific line item in our risk matrix or in our risk register. Continue to discover and probably quarterly assess the status of discovery,
Yes.
and also assess the emerging threats or the threats out there, whether that it could exploit them. Like you very rightly said, harvest today, decrypt later. Because today, I think a lot of people have this mindset: my data is encrypted, so it can't be broken. So I think that's what you're trying to highlight here. Anish, I know you're trying to say something. Tell me.
Yeah, so that is very much important, because the whole essence is that on the term when we use it as crypto agility, where we are moving from the classical algorithms to a quantum um, style algorithm, and it should be seamless. We have to reduce the disruption. It is so easy to sit and talk from a theoretical point, but when it comes to the practical side, it's going to be difficult. So we need to make that agility as much as possible.
Anish, thank you so much. It's been wonderful talking to you. So, viewers, there are a few takeaways. You need to start the discovery process today. That journey has to start today. You need to discover your digital assets, understand where there is an intersection of cryptography or crypto systems, where quantum technology can be used to break those controls. And as Anish rightly mentioned towards the latter part of the conversation, how agile are you in adopting crypto systems so that you can stay ahead of the threat? So, with that note, uh, Anish and I also agreed that we would come back and talk in depth about some of these intricate areas in another session. So, Anish, once again, thank you so much and see you again in another session.
Thank you, Sujat. Looking forward.